Welcome back everyone to another video here on the Unknown Coder YouTube channel. Today we are taking a look at problem number 151, reverse words in a string. This is another medium problem, but it's not too bad once you figure out how to actually get this all working. The problem states, given an input string s, reverse the order of the words. Now the thing to note here is that it wants to reverse the order, not actually reverse the string itself. And it says a word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Now again, this at least one space is something we need to note here, and it will say a little bit later that sometimes there might be extra spaces. So what we want to do is return a string of the words in reverse order, concatenated by a single space. So again, it does not want us to actually reverse the words themselves. It just wants us to reverse the order in which we see the words inside of the string. Finally, note that S may contain leading or trailing spaces, or multiple spaces between two words. Again, this means that there could possibly be a whole bunch of extra spaces in here that we want to ignore. We only want to be able to return single spaces in between these words. The return string should only have a single space separating the words. Do not include any of these extra spaces. So again, this is going to be really important. We want to make sure we get rid of all of those. So before we get anything too crazy, let's go ahead and take a look at the examples. So for example number 1, we're going to be given a string with the sky is blue. Now this string doesn't have any extra space or anything. So what we do for the output, we take the last word and put it first, so that'd be blue. Then the next word is, the next word is sky, the last word is the. So then we return blue is the sky because that is reversed. This one didn't have any extra space or anything we had to worry about. This one we just copy them straight over. In example number 2, we're going to be given the input string of hello world, except this one's going to have extra spaces on the front and back. So for this one, the output would be, we need to first ignore these last two spaces, then copy over the word world. Then of course we would go ahead and copy over the next space and then copy over hello. And then the last two spaces in the beginning would be ignored. So then we would just return world hello. Finally, for example 3, we have a string called a good example, except between good and example, there's a couple extra spaces. So for the output, once again, the first word is example, so we'd copy that over. We'd have one space there, and then we ignore the extra spaces between example and good. We'd go ahead and copy over good, and then finally we'd copy over A, and that would be the output, and we would go ahead and return that. We'd go ahead and ignore those extra spaces in the middle, and make sure there's just one there. So let's go ahead and take a look at the constraints before hopping into our example walkthrough. So the constraints for this one are relatively simple. The first one says 1 is less than or equal to s.length is less than or equal to 10 to the 4. This just means that the length of the string is between 1 and 1000. So again, these are pretty small numbers, pretty arbitrary, so there's nothing we really need to worry about here. Next states that s contains English characters, uppercase and lowercase, digits and spaces. This just means that we don't have to look for any weird characters or anything that we're not going to be expecting. We'll just be looking for regular letters and digits for the words and then spaces in between, so nothing to worry about there. And finally, there's at least one word in S. This is pretty self-explanatory. No matter what we do, we're always going to have some sort of word to go ahead and move. And at the end of the day, if there's only one word, if you reverse it, it's still going to be the first word. So nothing to worry about there. So once again, the goal of this problem is to detect each instance of a word, ignoring extra white spaces anywhere in the string, and then reverse the order of those words inside the string. And once again, the ordering of the words or the ordering of the characters in the words are going to stay the same. We're just actually reordering the sentence itself. So this is a medium problem that doesn't necessarily have a pattern. You just kind of have to figure out the different parts involved to get it to work. The first step is going to determine which indexes of the string contain a word, quote unquote. So basically we need to figure out where each of the words are. We can determine this by looking for letters or digits in between space characters. Then we also want to go ahead and ignore all the spaces that we find. Then we must copy those characters at the indexes we found to a new string in the correct order, and also be sure to copy over at least one single space between each of these words before moving on to the next. These two steps seem pretty simple enough, so let's go ahead and dive into the pseudocode and take a look at the example walkthrough before moving on to LeetCode. So the pseudocode is actually pretty simple. We're going to go ahead and say let result be a new string. This is obviously what we're going to return. Then we want to say while we haven't looped through S, starting from the end. We want to say while current character is a space, ignore it. Then we want to say while current character is not a space. We want to count the indexes of the non-space characters. Then what we want to do once we find all the characters in that word, we want to add the word we found at the end of S to the front of result. We also want to go ahead and make sure we add a space at the end of the word. Then when we're finished, we'll go ahead and return that result. Like I said, pretty simple. We just have to find the words, go ahead and add them to the beginning of the array, and go ahead and continue from there. So let's go ahead and hop into our example. Unfortunately, this example is very large. It's going to take many different pages to actually explain. I'm going to try to do my best to keep everything on here as best as I can, but we're going to go with the example s equal to hello world with extra spaces at the front and the beginning. So we're going to start with I equals 0, and our res will be an empty array. And just to kind of keep in mind, we're going to treat the strings as an array, just kind of to make it easier on ourselves for the example, so don't get too confused here. So we're going to say res is equal to an empty array, and our right index will be 14. This is the last index of our string, and then index is equal to 0. So the first step of this big while loop is checking while character is space. So we'll say j equal to 0, right equal to 14, and our s of right is equal to a space. This means we want to say right minus minus. We'll move on. J equal 1, right is equal to 13, s of right is another space. Now we say right minus minus, j equal to 3, right is equal to 12, s of right is equal to d. So now this is no longer a space. We're going to go ahead and break. We're going to go ahead and set our left index equal to right. And now we need to check while character is not equal to space. So once again, j equal to 0, right is equal to 12, s of right is equal to d. So now we say right minus minus, j equal to 1, right is equal to 11, s of right is equal to l, so right minus minus, j equal to 2, right is equal to 10, s of right is equal to r, right minus minus, j equal to 3, right is equal to 9, s of right is equal to o, right minus minus, j equal to 4, right is equal to 8, s of right is equal to w, and then right minus minus, j equal to 5, right is equal to 7, s of right is equal to space. So now we need to go ahead and break. Now we have found our first word. So the first word will be between index 12 and 7. So now we're going to go and copy that first word. So j equal to 6, index equal to 0. We're going to say res of index plus plus is equal to s of j, which is equal to w. J equal to 7, index is equal to 1. Res of index plus plus is equal to s of j, which is equal to o. J equal to 8, index is equal to 2. Res of index plus plus is equal to s of j, which is equal to r. J equal to 9, index is equal to 3. Res of index plus plus is equal to s of j, which is equal to l. J equal to 10, index is equal to 4, res of index plus plus is equal to s of j, which is equal to d, j equal to 11, index equal to 5, res of index plus plus is equal to a space, and we go ahead and break. So that is the entirety of the first iteration. Like I said, this is going to be a little bit of a longer one because we have a lot of different steps inside of one single iteration, but now we're ready for iteration I equal to 1. I equal to 1, res is now equal to world space, right is equal to 7, and index is equal to 6. So once again, while character is a space, so we say j equal to 0, right is equal to 7, s of right is equal to a space. We say right minus minus. Now j equal to 1, right is equal to 6, s of right is equal to o. So this is no longer a space, so we'll go ahead and break. So that's the first step. Now we need to go ahead and set left equal to right, which is equal to 6. We need to go ahead and say while character is not a space, so j equal to 0, right is equal to 6, and s of right is equal to o. We say right minus minus, j equal to 1, right is equal to 5, s of right is equal to l, right minus minus, j equal to 2, right is equal to 4, s of right is equal to e, right minus minus, j equal to 3, right is equal to 3, s of right is equal to h, right minus minus, j equal to 5, right is equal to 1, s of right is equal to space. So now we go ahead and break out of our loop. Now we know the second word is between index 1 and 6. Let's go ahead and copy that. So for j equal to 2, index equal to 6, we're going to say res of index plus plus is equal to s of j, which is equal to h. For j equal to 3, index is equal to 7, res of index plus plus is equal to s of j, which is equal to e. J equal to 4, index is equal to 8, res of index plus plus is equal to s of j, which is equal to l. J equal to 5, index is equal to 9, res of index plus plus equal to s of j, which is equal to l. J equal to 6, index is equal to 10, res of index plus plus equal to s of j, which is equal to o. J equal to 7, index equal to 11, res of index plus plus is equal to a space. Now we're finished, so we go ahead and break. So that completes the second iteration, or I equal to 1. So now we have one more iteration. For I equal to 2, res is equal to world hello, right is equal to 1, index is equal to 11. So now we say while current character is a space, we say j equal to 0, right is equal to 1, so s of right is equal to a space. So once again, right minus minus, j equal to 1, right is equal to 0, s of right is equal to a space. Once again, right minus minus. So now right is less than 0, which means our while loop is over. So now we need to remove the trailing space from res and go ahead and return res as a string. So like I said, all of the examples are pretty long, so I just kind of chose the best one. So let's go ahead and hop into LeetCode and take a look how we can code this out in Java. We start with a char s array is equal to s.toChar array. Then char res array is equal to new char array of s array.length plus 1. And int right index will be equal to sArray.length minus 1, int index is equal to 0, then while right index is greater than or equal to 0, while right index is greater than or equal to 0, and sArray of right index is equal to space, right index minus minus, int left index is equal to right index, while right index is greater than or equal to 0, and sArray of right index not equal to space, right index minus minus, then for int I equal to right index plus 1, I is less than or equal to left index, I plus plus, res of index plus plus is equal to sArray of I, and if I is equal to left index, res of index plus plus is equal to space. Finally, outside of the while loop, we're going to say if index equal to 0, return an empty string, otherwise return a new string with the res array 0 and index minus 1. Now we hope that inside of this I didn't typo. There's a very high chance, so if I did, I'll fix it and resubmit. And there we have it. Once I got rid of all of the typos, everything's working. Now it says there's a 2 millisecond runtime. There's one that beats it. However, I've literally copied and pasted the one that says it quote unquote beats this, and it still gets 2 milliseconds. So I think that LeetCode is either more lenient sometimes, or things are just a little bit strange, but that beats 99.86, so fairly good. It also beats 99.95% of the memory complexity, so that's very good as well. As always, if you guys did find some value in this, please leave a like, comment, and subscribe. It always helps me out on the YouTube journey. As always, I'm Ethan, or an Encoder. Hope you have a great day, and I'll see you all in the next video.